Well, thank you for having me here at Ekoparty. And also welcome to Ekoparty 2008. The talk today, to start us off, is on the economies of scale and hacking. As CTO of Immunity, obviously I try to make sure we don't get crushed by the giant powers that be. But understanding the sort of sweep of how things are headed, the trends, is important for almost all of us to figure out what technologies are good, what technologies are bad but being marketed very well, and where we need to go. So with no further ado, most people probably do not have a large background in economics, as I do not. But just in brief, economies of scale essentially devolve into two sides. You can see there's sort of supply side and demand side. So the typical example, if you're going to read the literature on demand side, is fax machines, right? One fax machine is pretty useless. Two fax machines pretty useless. But if everybody has a fax machine, then they're darn useful, right? So that's one side of the equation. The other side of the equation essentially is going to be supply side economies of scale, where you have a very high barrier of entry, and you get the ability to make things much cheaper as you get bigger. So for example, one of the typical things people will say is if you look at an airplane, the first one you build is going to be humongously expensive, and the second one, much less so. You'll actually know how to make an engine and so forth. So these are if you look at our industry, there's a lot of sort of business side things you can look at where you get economies of scale. There's also the sort of technological side of looking at economies of scale. And that's kind of where we tend to focus as technologists, probably to our own chagrin. So this little picture of Janus. Luli told me what the Spanish name for that was earlier, but it's the Greek god with the two faces. Essentially, the two sides that I tend to focus on at Immunity, looking at how hacking gets economies of scale. You will see sort of an offensive customer relations part of it, and you will also see the internal infrastructure overcoming high barriers of entry and looking to leverage that sort of thing. Now, when we talk customers as hackers, we don't necessarily mean people who buy Canvas, people who buy our software, our products. We generally mean targets, right? Your customers are the people you're trying to hack into. That's in reality how the equations work. So as we go forth, we'll keep that in mind. And here's, in general, what we see is that there is an underlying economics to how the technology works. And when people sort of decide to ignore that or try to go against that, which we call going against the gradient, they end up having technology that, even if it sells very well, doesn't in fact work. So I thought we'd take a few examples here of things that don't work. And my apologies to the antivirus and IDS vendors in the audience, and the static analysis vendors. So when you look at these technologies, the questions you want to ask essentially in your head are, what part of this technology is going to end up growing exponentially, and how is the technology going to handle that? And we have a few quickie examples. Has anyone here used Twitter? Do I see any hands? All right, we have a few people who use Twitter, which is it's essentially IRC that works over the phone and the web via a very tiny little website. And they wrote it on Ruby on Rails, and essentially there will be only one Twitter-like service because the network effects are just so strong. Unless all your friends are on Twitter, there's no reason for you to be on Twitter. So there's only going to be one. But Twitter itself, possibly because it was written on Ruby on Rails or possibly for some other reason, has a horrible tendency to fail anytime a large event happens, because everyone tries to use it at once and it just goes down. So essentially what in my head, I think that anytime you see something failing under exponential growth, I think of it as twittering. So this is kind of a sign when you're looking at how is this stuff going to fare? One, is there exponential growth in what they're trying to do? And two, is that going to work? And if you look at the antivirus community, they're saying that we are doing a fantastic job. Check out how much more stuff we can handle this year. And that's what F-Secure put out. They said, hey, malware doubled. We now have some 500,000 signatures in our database. So every binary you run is getting checked against 500,000 things. And that's a lot of things for me just trying to run command.exe. And likewise, you had one of the top executives at Microsoft saying, yeah, I'm going to install a Vista laptop at home, but I'm not going to bother to install antivirus on it because I don't think it's a prudent security measure. It doesn't work, is what he's saying. It doesn't work. It's annoying. Maybe not in that George Bush accent, but he's still saying it. The other thing you saw was this race to zero thing at the last DEF CON. Race to zero was a couple guys who got together and had a little contest, and they're saying, here's the major antiviruses. There's 10 of them, or 12 of them or something. We'll have all 10 of them, and we'll have some very simple vulnerabilities or worms or something that you're going to have to mutate to get through the antivirus, but they still have to work. So it's not completely trivial. You can't just erase the thing. That's, of course, going to get past the antivirus, but it won't work. So it still has to work. And the winning team did it in 6 hours for every sample that they had. 6 hours is not a long time if you're a giant, multinational crime syndicate. 6 hours with a couple guys, you can probably do that in your sleep. So you're looking at sort of a catastrophic failure of the technology. Now, whether or not it's installed on 50 million machines this year and 50 billion machines next year and makes, who knows what kind of profit level, that's great. But the technology doesn't work. And eventually, it's destined for market loss. And you look at IDS in the same way. You say, what is growing exponentially? And what's growing exponentially is the complexity of what they have to do. Right? The complexity is I have to parse Ethernet layer, I have to parse IP layer, then I have to parse TCP layer, then SMB, then all the way up into DCOM and all the, everything above that. Maybe I have to parse Groove today, right? Nothing more fun than decoding Microsoft's Groove protocol. So even if let's say I get SMB completely right, and I've got a huge state table, and I've parsed it out perfectly, Samba's coming out with a new vulnerability in their new version, and that's going to be maybe a slightly different SMB. So I'm like, all right, and you can see this is what Snort did, right? Snort said, okay, now I will figure out what the targets in my network are, and I will model their network stacks. So now in Snort, you have multiple network stacks modeling each different kind of target. So for OpenBSD, they defragment one way, and for Linux, they defragment another way. And then what you're going to end up getting is, oh wait, that's Linux 2.6.27. He needs a slightly different defragmentation protocol, right? So now they're going to have an entire array, like an exponentially growing network stack that has to encompass all possible network stacks for all possible protocols. So the protocol complexity gets insanely bad, insanely fast. And doing something like DCOM is in fact nearly impossible to begin with. So the exponential growth and complexity is there's going to be a point where everyone realizes it doesn't work. And of course, this doesn't even take into account the natural tendency for people to use encryption on their networks. Many people, and you see it all the time, the lost dream of static analysis. I know, here's what I'll do. I will take the program as a binary, and I will translate it into an intermediate language. And once I've done that, I will run signatures against it, and I will find all the vulnerabilities. How many people have said that to themselves, right? I know I have, right? You think, oh, I could do it, I could do it. You can't do it. And here's why. All the products in the market, some of them have had millions and millions and millions of dollars of research effort put into them. All of them are written by extremely brilliant people, with tons of brilliant people, PhD level, everyone smart, every good hacker has tried it. You get 6 target programs in the NIST Static Analysis Survey, and NIST, for those of you who are not Americans, is the National Institute of Standards and Technology. They're a government group full of smart people who try to see if stuff works and how they can compare it. So they took 6 target programs, 3 C programs that had not been overly analyzed by everyone else before, Nagios and Tiny HTTPD and a couple others. And the Java things were basic, simple Java programs for Tomcat or whatever. And they ran them through every single kind of static analysis program they could find, including services. There's plenty of things out there that won't give you the actual static analysis tool, but they will run it through it for you, and then they'll give it to you. Full source code, everything, all open source stuff. And they ran it through about 10 or 12 different kinds of static analysis checkers. They ended up with 47,000 warnings, which they normalized and put in XML format and compared and contrasted. What they found was that in some cases, they're getting a false positive rate of something like 80%. 80% is pretty high, right? Like if you have a false positive rate above 2 or 3%, no one can use your tool. It just doesn't work. 80% is just funny. At least I find it funny. Maybe they find it funny. But they had Steve Christie looking through all the different warnings, trying to figure out which ones are true and which ones are false positives. And they don't even care about false negatives. If you have 0 false negatives, 100% false negatives, they don't care. But what they found was they had about 47,000 of them to do. It took them about 15 minutes at best to do one. They're looking at about a man-year of effort to do these 6 tiny little programs. A man-year from a smart dude after running all their static analysis tools on it. Can anyone guess how many awesome ODE they found? Open source C programs written by normal people? Is it possible to write a C program without a buffer overflow? No. So they didn't find anything. They found 0 ODE. Out of all the money they've spent on static analysis, they've wasted exactly 100% of it, right? And it's just continuing to happen. This is what's going to happen. You're going to see a huge market for static analysis. People will pay tons of money for it. None of it will help. And realistically, the reason is no one wants a checklist, right? You get this big checklist from Fortify, you get this big checklist from all the others. It just doesn't work. And you'll start seeing them differentiate in other ways. Like the ounce guys are exposing their API, and everyone else has static plus dynamic plus this plus that. So, but it's very interesting, the lost dream of static analysis. And here's realistically what the root of our problems is, or the root of our solutions, realistically. For those of you who do not recognize Alanis Morissette, she was a world-famous singer in the 90s. So if you have a security problem, in the 90s, you had 2 things you did, and then you got VC money for it, right? You said, I know what I'll do. I will sniff for things that look like that problem, and then I will put an alert into your management system. And the other thing you did was you said, I know what I'll do. I will scan for it on your network, right? We all have this. This is what you got on your, if you get like Backtrack 3 or whatever, you're going to get 300 programs that either sniff for stuff or scan for stuff, right? None of that stuff works. And the reason is that both of those are exponential functions. Because scanning for stuff is exponential, and sniffing for stuff is exponential, and if you actually have to do real work, they both generate false positives like crazy. So that was best of the 90s, kind of like some sort of fashion-y thing that we don't wear anymore, and we should not. Although it is coming back into style. So if you look at how the world really works, you say, these are the mistakes we made. Now, why did we make them? How can we change it? What's the future going to look like? You start looking at, will we be around in the next 10 years? And you say, well, the best offense is a good offense. That's just the way of life. Sort of a personal philosophy. And the reason you start thinking about that is, well, if I look at how hackers work, what is the best password cracker in the world? What is it? John, all right, John is the best password cracker in the world because it has the simplest name to pronounce. But this is what my friends say. They say, I don't use a password cracker. I just grep for your name and your user ID in my giant list of passwords that I have that I stole off every machine I own. And I'll probably have you, right? I have an 80% chance of having you in that list. That's what they say. So realistically, once you've hacked a bunch of stuff, hacking other stuff becomes much easier. It's sort of the, you have to maintain it. Maintaining a hacked machine is like one-man job, right? It's like a man-year to get Let's say you have 10 machines you can maintain. You got to check the Trojans. You got to make sure you update with them. You got to make sure they haven't found you yet. All that stuff, that's super expensive, which kind of feeds into the other side of the story, which is your supply side, economics of scale. And again, one of our people released a paper not too long ago at Black Hat Federal, where he detailed the results of some efforts. And one of the things he noted was, if I sit on your mail server for something like 6 months, and I just read all of your email for 6 months, I've now built a complete web of trust for you, and I know exactly that every quarter you're going to get a new binary from, Bob the binary guy, and he's going to email it to you, you're going to run it, right? I don't need to client side you. I just need to be Bob the binary guy that quarter. And knowing everything about everyone makes your life a ton easier. I don't have to spider the web looking for your email. I know your email because I know everyone's email because everyone emails each other. That's what it's for. So this is, once you're everywhere, you have a much easier problem to solve. You don't have to solve the problem of locating people's networks. I just know the networks. Likewise, there is a real issue if you're a professional attacker with not being seen by everyone and their brother as you do your work. And you can't avoid it because like Kalia in the States and everywhere else, people are on the main routers and they have a sniffer tap to it and they scan it all, right? They're like, well, I'll just store all the traffic off May East or whatever, which is great and all for them because they're back in the 90s. But nonetheless, we want to avoid that. And how do we avoid that? And this is how you do it. You pretty much tunnel between yourself and a bounce target that's so close to the target that, oh, you're loving those graphics, aren't you? You're like, yeah, that's OpenOffice, man. You should buy a Mac. But, yeah, we don't have Macs. So realistically, once you can be close enough that perhaps I'm even on their local ISP, I'm on the LAN, I don't necessarily have to go through a satellite hop, right? There's no way you can sniff me, that I'm just not there. I'm some traffic to someone else. And if I can do that for any given target, you give me a network, I'll tell you where my closest machine is. That allows me to avoid law enforcement at a strategic level, right? Or anyone sniffing me. So if you are a hacker, this is how you do it. And again, we do a lot of consulting. And one of the things that you hear when you do consulting, especially with financial, SCADA, or anything else, is that, well, you did really well, and you owned our system pretty good, but you have a lot of access to our developers, you have the source code, and you sat around, you can read our documentation. No one else would have that. So realistically, I don't have to worry about these problems that much because they're basically impossible to figure out. And like all information, source code wants to be free. And it's weird because in the 90s, I don't know if you remember, but source code was free for pretty much everything, right? If you were on IRC, I guarantee you had full source code to pretty much anything you wanted. And that was just because you asked for it. Here's Kevin Mitnick, and Kevin Mitnick, what did he get in trouble for? He got in trouble for stealing source code, right? More than anything else, aside from just being generally annoying to law enforcement and making them look bad. He got in trouble for stealing source code. And this here is one of the companies he hacked into. And when we say hacked into, I think he called them up and asked them to send him a tape of their source code. I think that's how he did it. He's like, hey, can I have all your source code? And they sent it to him to a PO box. And then now they're assessing their damages, which honestly I think they should have charged him for postage. But instead, they decided to charge him for the full cost of their source code and all of their research and development exercise across that whole platform, which they come out to $2,100,000. Well, but I think in one sense, they're just being really, really mean. On the other hand, they're probably, in one way, right. If your source code is out there, you face the strategic problem of having to actually acknowledge your vulnerabilities. You can't sort of hide them. You can't claim in your head that they don't really exist because no one has the source code. And if you're a good enough hacker, that is still true. You still have the source code to everything. So you are at a strategic advantage because people have this conception that their vulnerabilities are not exploitable or not findable, when in fact you know everything. And again, networking is complex, and this is the thing with scanning. Why does scanning fail so badly? One of the reasons is that networking is not as simple as it looks like. And the answer most people will say is, I know what I'll do. I have these little 1U boxes, and I'll go put them behind your firewall, right? That's, if you call up like Qualys right now and you say, I want a Qualys box, I need one for every subnet, right? And they're like, great, we'll ship them right out to you, right? Those things will work like candy. The problem is you don't really know where all your subnets are. You don't know your networking infrastructure. You don't know if the switch is doing firewalls. You know, maybe that Linux machine in the corner has a whole NAT behind it. And as IP6 gets here, which adds the complexity level to another entire exciting generation, it's only going to get worse. So, yeah, you can see some more open office graphics there. But for sure, this is what they want you to do, and the reality is you have to already know the network that you're attacking. You can't scan for it. You have to know it. And you don't know it by looking, you know, at their Cisco router tables. You know it by looking at the traffic that moves around the network. And if you're a good enough hacker, you probably already have this, right? You sit around, you look at who your machine's talking to and who it talks to and all the other machines around it, and you'll know exactly what they've got, because scanning is for suckers. And this is the other thing you see is, if you look at how Google does translation, they don't do it the way all the previous 90s generation technology did it, which was develop a giant grammatical model and a lot of math. Instead, they took a bunch of things that were translated and did statistical analysis on it, and then they have a statistical analysis engine that just does it, right? And it works better that way. And then you can actually have people submit, you know, have you ever used Google Translate in Chinese? And it says, can you suggest a better translation? And then you put in something horribly wrong, like peanut butter and jelly. And then, that's just me, I guess. The thing about OS detection, people get very focused on this, right? Like Nmap, for example. It's a great tool of the 90s. And it's in the matrix, like all good technologies. From the 90s. OS detection is such a 90s concept. You don't care what OS it is. You care if it's vulnerable to something, right? I don't even care if it's Solaris. If it's vulnerable to my Microsoft RPC attack, so be it, right? The thing that you do is you build a statistical model by getting a ton of data, and you say yes or no, you are vulnerable or not. If you're Windows 2000, that's great. I don't care either way. Right? Maybe you're Windows 2000 Japanese and I don't have a target for it. So my statistical model knows that I shouldn't have a target for it and doesn't even bother attacking it. It's not up to me, the heuristic builder, to build the perfect heuristic every time I want to write an attack. That's not the way things work. So you're going to start seeing statistical techniques take over where heuristics used to be king in security. And when you see someone doing that is where you look for actual success. But until then, you can have some fun. Someone tells me jetasm is Spanish for gypsy-like, which is not what I meant, but it kind of works. Essentially, Git, or JIT, I don't know how Linus pronounces it, is the Linus Torvalds tool for doing version control in a distributed fashion. It's reasonably good. We don't use it at Immunity because we're not distributed like that. We're all one thing. We're an army of one. That's a little American joke for you. But the reality is, if you take what you know and you distribute it and centralize it properly, you are much more powerful as a large organization than any small organization could be. And there's tools coming out to help you take advantage of that. Right now, I say there's no I in hacking, and part of that's just to test your OCD, because if you are, like most of us, a bit OCD, your brain immediately said, yes, there is. It's right after the K, which I get all the time. But the reality is, there's a lot of new tools that are coming out that are looking to take what you know about a program and put it in a database. And if you've listened to Halvar Flake at all, you realize that what he's saying is, I don't necessarily want the disassembly. I don't necessarily want like pseudocode from C. I want understanding. I'm looking for the analysis. What is it you actually want to know? It's not the C code, because we already know static analysis fails. It's understanding, right? So if you're looking at BinNavi 2.0, which is in the right-hand screen, or Immunity Debugger, or any of the other new tools, what you're going to end up seeing is they're going to all communicate and store everything they know about a program or a DLL or any little piece of code in a giant database that's going to be central to your organization. Your organizational effort will be, I never ever want to disassemble one thing twice. Why should I do that? How many people have disassembled the Microsoft RPC stuff and then had the guy next to them disassemble like a slightly different version, and then you have to compare and contrast and see what you think about each one? Is the vulnerability there? So that's all going away. If you are big enough, you can have your own private database of all code that you are ever going to be interested in, already analyzed for you by someone else in your organization. It's just going to happen. It's the opposite of code reuse. It's sort of like understanding reuse. And there's also a trend. People look at like exploits. Exploits used to be written by a guy, right? You have a name at the top. Who wrote this exploit? If you look at Millworm, each one has a name attached to it, which is very 90s thinking, because no one person at Immunity writes any exploit. It's always written by 2, 3, 10 people, right? If you have a hard exploit, it's 10 people. That's how many people you're putting on it. And how do you organize those people, and how do you put them together on one problem? And if you've got 10 people solving your problem instead of one, there's going to be problems you solve that people thought were not solvable. That's the difference. And so if you're big enough, you get an economy of scale here as well. So attack frameworks, you start seeing, like, obviously there's a push, a market push for attack frameworks from the 90s. There's an echo to push them towards vulnerability assessment tools, right? I want you to scan my network. And then there's another push where you say, let's get out of the 90s, let's build an iTunes for exploits. I want everyone to be able to submit their song to me, and then I want them to get the money from selling it, and I'll take a small fee for it. There's a Facebook for Trojans, right? Like, I don't want to talk to my targets as if, you know, we're all in some sort of weird chain of command. I want to talk to them the way I talk to my friends on Facebook, right? Like, occasionally you're there, occasionally you're not there. That's the way real networks work. There's a temporal sense to things. Things change, things move. Things are only online maybe Saturdays at 2 p.m., because that's when Quake time is, or World of Warcraft, since we're not in the 90s anymore. The fact is, if you look at open source intelligence, what you're looking for is a customer relationship management system for your customers, which are your targets, right? I want to know who you know. I want to know your CV. You used to be Solaris, but now you're Windows. I want to know everything, right? These are the things you're going to see in the attack frameworks of tomorrow, because they're not exploit frameworks anymore. Exploit frameworks also very 90s. So again, why? What is going to chop off the bottom layer of this stuff? What is it? When you look for economies of scale, you look for things where no one can go there because you can't get the capital together to get into the market. And most people cannot get the capital now to get into the market of heap overflows. The capital being the skills, the technologies. You got to train up a ton of people to do your first one. And if you do your first one, I guarantee you it's not on Vista, right? You're not even close to modern technology with your first overflow. And that didn't used to be true. It used to be you read LF Swan paper, and then you wrote an overflow against IMAP or some random thing, and then you were as good as you needed to be, right? That's not true anymore. Why? Because the security research has now cost money. It costs like dollars or pesos or whatever it is, and you don't just give it necessarily away during conferences as much as you used to, right? If you read BugTrack, it used to be useful. No one here reads BugTrack every day anymore. I used to, like, the first thing it used to be when you joined my team was go read all the BugTracks starting at the beginning. When you're done for the day. That used to be like the entry-level course. But nowadays, BugTrack is completely useless, right? The people just aren't giving their stuff away like that. And the reason is it's too expensive to do in your spare time with one guy. And when you buy something these days, Immunity, like many companies, participates in the purchase of vulnerability information. And we don't just buy things because they're a good vulnerability that works on a certain target. Often you're buying something that you don't care about the target, but you definitely care about the way he exploited it, or she, or they. Maybe you're buying it because you've not seen a good example of that vulnerability class being exploited before, and you want to see just, is this actually exploitable or not? How reliable is it? Let's get some real test data on it. So you're not, people call it a vulnerability marketplace, but it's not. It's an audit technologies marketplace. How did you find this? And say, how did you exploit this, and what else can be exploited similar to this? That's the marketplace. And this is much, much more interesting than the sort of publicly acknowledged vulnerability marketplace, which is just essentially IP. Another 90s movie I liked. All right, so what is it that makes it so expensive? How do you raise the price to cut everyone else out of the market? Heap and stack cookies, right? If you have the /gs or whatever the default Linux compiler uses. Safe SEH, ASLR, which is now in Vista and probably coming out in Windows 7 and Windows 2008. DEP, NX, WXORX, or as they should all be known, PAX. And of course, managed languages, right? When people are writing in Java, we thought that was really annoying because Java has no buffer overflows. But now that C# is the first language people learn, or ASP.NET's what they're doing, right? All that stuff cuts off most of the market. So how did that happen to us? Well, it's Andrew Cushman's fault. Security got built into all the development life cycles, which is, I guess, Steve Lipner's fault, really. The compiler tools all got good. Everyone made a lot of money differentiating themselves from other vendors using security. If you go up to the Microsoft SQL booth, they're going to be selling SQL Server, and there'll be a little pamphlet you can pick up about how bad the security is of Oracle and MySQL in comparison. And they're probably right. And of course, as they build all the security into their platforms, the cost goes up. Of course, for most of you who do security, you think, why do I even care about security? Everything I do is in Ruby, and if I look at IIS, there hasn't been a remote buffer overflow since version 5. Version 5 was Windows 2000, right? That's 8 years ago. You're telling me there hasn't been anything exploitable remotely in IIS for 8 years? That's awesome. That's crazy. And it might not be true, right? Because when it gets to a certain point where it's really hard, it's not going to come out publicly. You're not going to hear about it. And of course, people, now that they're using managed languages, they're like, it's managed. I don't have to worry about this stuff anymore, which is great. But part of the reason they don't have to worry about stuff anymore is because we used to do vulnerability research as our marketing team, right? Realistically, there's like a dotted line between VP of marketing and your VP of engineering, and that was your vulnerability research, right? If anyone's looked at advisories, which are totally 90s, right? Immunity doesn't do advisories because we're already famous enough. But if you look at X-Force or anyone at Stake, which I used to be in, all these companies, why are they doing so many advisories? It's because their marketing budget's not big enough, right? But now, vulnerability research is so frickin' expensive that you can't get it out of your marketing budget anymore. You have to have a real reason. And if you start giving up your best techniques for free in advisories, everything, your VP engineering is going to get very upset with you for using up all of his budget for something that's not giving him any return on investment at all. And again, so people aren't necessarily investing in finding bugs the way they used to for that reason. And of course, the techniques for exploiting them also are very expensive. So that's sort of something you spend once a lot on, and you get that from many vulnerabilities. And as it gets more and more expensive, people stop releasing, and you don't know if a vulnerability is exploitable or not when one does come out. So if a vulnerability comes out, and you have to make the choice, do I patch it or not, you're going to make that choice based on whether you think it's exploitable. Will it really be a problem? And the answer will probably be no, because you don't know, because no one's released anything like that. You start seeing things like the Microsoft Exploitability Index, which they're doing to add a level of certainty to how you make these decisions. Where do you really spend your money? But what if everything says pretty much not exploitable, right? Which is, I mean, the trend is definitely going to be towards pretty much not exploitable. And that's going to change the way people spend their money. So in that case, you're going to see people stop investing in security. That's just the way it works. And this is what happens then, is that people who are big look at things and say, no one else can afford to eat here, right? If you're on the African savannah, a giraffe can wander around in the forest, and there won't be anything below 6 feet to eat, because the antelope have eaten all that, and they've all moved on. It's a desert, right? But the fact is, a giraffe is doing all right, even though it's humongous and eats a lot, because it can eat everything on the top of the treetops. And that's who you have to be to survive in a world where everything is this expensive and this difficult. You have to be a giraffe. You have to invest in growing your neck. That's what Immunity Debugger is. That's what BinNavi is. That's what all these hacker tools are that do analysis and things, learn how to do coordination and teamwork, figure out how the heap model works, do all that extensive work, which realistically you didn't have to do 5 years ago, and you don't really have to do today, but you will have to do it tomorrow, and they're growing their neck to get to that next leaf. And what they're going to end up doing is defeating secure development life cycles, which by themselves, of course, are like all software. If you start hearing about this stuff, it is something that has an initial resilience and then a catastrophic failure. And if you're a large organization, you're looking for that catastrophic failure, because that's where you're starting to feed. And of course, you may not necessarily be just using your vulnerability information. You may be doing an entirely different set of things in order to learn about the way electronics work or something else to combine with what your sort of vulnerability team is doing to attain hard problems. So the next big mistake, you're not going to see people talking about it publicly in terms of how to exploit it or how to do anything with it, but the next big mistake is threading, right? In C and C++ world, we all concentrate heavily on like memory, right? If you can do things with pointers in memory, life gets very bad. But realistically, threading is just as bad an idea as an unmanaged string library. Threading, when you do thread, you might as well be calling strcpy, right? That's how bad it is. And everyone still thinks it's a good idea. And 10 years from now, we'll look back on it and we'll think, why did we not manage our threads the way we manage our libraries, right? Like, everything else is ridiculous. And you see a little bit in Erlang, where they're like, oh, this threading thing, it's hard. Let's deal with that. But realistically, there's not a whole lot of research going into the threading problem. And that'll probably stay the way it is, luckily for us. And that's where you come to. You come to like, well, I've looked at all these things. If you look at the environment you're in, there is a trend towards a natural monopoly, meaning these things all combine up together. And if the market were just to play out, there'd be one person doing hacking or one organization. Of course, economics will tell you that there's lots of things that distort the way things normally are. One of those things is governments and big corporations can afford to pour money into unprofitable areas and destroy natural monopolies or bubble around them. And that may be what we see. So that's, if you try to analyze what you do, I always try to analyze it in terms of, are we going against the gradient? And in some cases we are, and how do we prepare for that? And that is the talk. Hopefully you guys like the 90s less now. We'll see. Does anyone have any questions, or do they just want to raise their hand and say how smart you are? Please do. Does everyone understand my English? I do tend to talk pretty quick. I think I see someone's hand raised in the back, but it's probably a mirage. We can talk about heap overflows too. Cool. All right. One question. One brave man. Okay, so his question is, worms are over, but botnets still exist. which is true. But botnets essentially are not a problem that IPS and IDS are solving. I mean, I guess you can kind of make it a circle because they still exist. Therefore, they clearly must not be solved. But it's a good question. Yeah, why aren't we solving the botnet problem the way we solve the worm problem? And I think the answer is there's just too darn many of them. It's too easy to write a bot and too difficult to detect it. I mean, we can do it over HTTP with my botnets. If you look at some of the other botnet research we're doing, it's all over like weblogs. So unless your person doesn't communicate over weblogs, then it's very difficult to differentiate our bot from a real person or other stuff. Bots are fun. We all like bots. All right, so we had one question. And if we don't have any more questions, I guess we'll move on to the next talk. Thank you very much.